Hi, this is Dr. Liu. So what we're looking at is the Ohm's law's data analysis. So here, let's start from the top left. We have two different bulbs, and at room temperature, they each have their resistance measured, and these alpha values are from the lab manual. And then for tungsten, we have voltage that we apply, current we measure, resistance we calculate, power we calculate. And I'm hiding the rest of the data just in case someone wants to just pause the video and copy. You're not supposed to do that. So these two values are from the experiment. And to calculate the resistance, you just divide the voltage by the current. So that's how it's done. And to calculate power, you multiply voltage with current. That's that. And we did this, the tungsten. We also did carbon. And same thing, I copied the formula. So divide voltage by current to get resistance, multiply them together to get power. And then for each uh, filament, plot out voltage as y and current as x. So we'll have something that's roughly linear and we'll fit it with a curve and display the function or the formula including R square value. And that's the carbon that also has voltage versus current. And then separately, we also should plot resistance versus power. So resistance versus power basically from here. And that's carbon's resistance versus power. So you should say something about how resistance changes with power. Power is not proportional, but related to temperature. The higher the power, the higher the temperature of the filament. So you can say as temperature increases, how the resistance is reacting to that for tungsten and for carbon. And then also we're supposed to calculate for the filament temperature. So I calculate them to be 2600, 3800 for tungsten. That's typical. And for the carbon, it's only a few hundred, which makes some sense. But I thought this might be a little low because the carbon filament was glowing orange, so that indicates it is well at least maybe in the thousands of degrees C, but not as high as the tungsten, which is typically kind of white in color. But these numbers are what I got, so maybe they're not as accurate as what the tungsten calculations are. So the formulas to calculate the temperature is this. This is given temperature, calculate the resistance. So we have to invert this, and to invert it, we need to divide by R0, and then subtract a 1, divide by alpha, then add a 20. So that solves for T. So R0 are the resistance values at room temperature. And then we can use alpha from the textbook, from the reference or manual, and then we can calculate for temperature.